Okay, so we're going to begin writing the API here, and I'm going to I know we had written several parts of this in class, but I'm going to begin writing this in Scratch. Now, if you're watching this video for the first time, you might say, you didn't do this in class, and it's like, well, when I created these videos, I'd already done half of this in class. Um, so I'm going to just start from scratch, and so there could be some small variations from what we did in class to what we have here. So just be aware of those, and you might want to modify your code accordingly. So I'm going to do new project here. Um, Target device says last use here, but if we want to make sure, we can always say, okay, remember we're doing this for the PSOC4200. Is what we're doing now. I mean, you could apply this to other PSOC devices, but the PSOC 4200 is the one that I have with me right now, which is why I'm using it. And I'm just using this to create the API. As I said, you could use this for other PSOC devices. Um, so I'll start with an empty schematic, and I'm just going to call this MPL115A2 underscore I squared C code. And I like to use underscores as a side note. You probably notice I like using underscores, and that's because back when I was learning a program, you couldn't put spaces in things. And honestly, depending on the software you're looking at and how old it is, and what I mean by old, you might say, well, it's new, but well, sometimes they don't update certain features within software platforms, and sometimes they don't handle spaces always well. And that actually comes into play with a lot of SPICE simulators, circuit simulators, that can happen. I've seen it with modern releases of circuit simulators that are like released in 2018, and if you put spaces in your file names, they hate you. Which you'd think they would have fixed that by now, but sometimes they don't. Anyway, let's move on here. Now, what I'm going to do here is just create one block in here. We're not actually going to be programming our device per se. I mean, we will eventually here, but in order for me to thoroughly get everything in here, what I'm going to first do is just go ahead and drag in an I squared C block here. And that's because I'll be able to generate the API for it. Now, if you remember on the data sheet, it actually said that the maximum speed was 400. So we have different speeds that we can apply here. We didn't talk about this much. We just left it at 100, which is actually very slow because it's little k BPS, which is kilobits per second. Which is actually a very slow speed if you think about modern download speeds. But the reason it's slow is that if you think about how much data we're actually transferring on the I squared C bus, there's not much that we're transferring. So I always like to say the idea is like, well, use the right tool for the right job. I mean, if you have a finishing nail, you can use both a sledgehammer and a finishing hammer to drive the nail in. Probably want to use the finishing hammer as opposed to the sledgehammer. And so that's the same idea here. We don't have a lot of data being transferred, so why do we need high bandwidth? Why do we need high speed? We don't. We can get away with lower speeds because of the amount of data we're transferring. We're talking about bytes of data that we're transferring. All right, so again, we set it at master here, and then I'm just going to go ahead and generate my API. And I didn't place my pins, I know, but the pins are automatically placed in the correct position for the PSOC. Actually, I want to change one thing here. I want to change this name to I squared C. And then for those of you who might not have been part of the class at all so far, one thing I want to point out, and any kind of tutorial you see from Cypress points this out as well, is the data sheets that Cypress provides are invaluable. This is the data sheet for the I squared C, and you can just go to the I squared C APIs and it will tell you what commands you have available to you. It will tell you exactly how to use them, like what all the variables are that you need to give it, things of that nature. So it's very useful. Now, I'm not going to be referring to it because I know what we need to be doing, but that would be useful if you've never looked at those before, or if you're wondering how do I know all this? Well, it's from referencing the data sheets for these components. And I'm going to generate the API one more time, but you can see it automatically assigned these to port 4 pin 0, and you can see here that's just defined because for the 4200 it's got one serial bus, and these are the serial lines you need to put them on. So but I am going to regenerate the API because I changed the name from I2C_1 to just I2C, and these directories should then all update here in a second. Yeah, there they go. Alright, so the first thing I always say that you should do when you're writing an API is, well, first you should plan it out. You know, what kinds of functionality you're going to need, what kinds of things you're going to need to have here. But this is a fairly simple one. But once you have it planned out, which you should take a look at the data sheet and kind of figure out what kinds of measurements you're wanting to do, because the whole idea is you're trying to make this as easy on the user as possible. We don't want the user, for instance, I'm going to go back to the data sheet here. We don't want the user to have to remember, let me get to the memory map. We don't want the user to have to do any of this stuff of reading in the coefficients. We want to create an API that does all this, that uses the formulas here to compute the pressure, and then basically the user would only have to do like a start function and then read press, like for read pressure, and then they would be done. And it would get them to the pressure data, and there would be nothing else they have to do. That's what we want to create. So to create that, we're going to first, let me go back to the program here. I'm going to create a header file. Always, in my opinion, you create the header file first. So I'm going to create a new header file, and I'm going to call this MPL115A2. I always like to give it the name of the sensor I'm using. And it might seem like we're going to have to type an extra amount of information, but that is actually useful for us. And what I'm doing here is I'm just increasing the font here of the editor. Is that that's the text editor, general, fonts and colors. That's an assembly file. C/header file, that's what I want to do. And yeah, we'll make it a little bit bigger here. Alright, so you should always put some information here about what this is, MPL115A2 API, or pressure and temperature sensor API. And you might want to put some other information like, you know, licensing information, things of that nature. Mine are always general use licenses when I create code, but it's important, and if you're ever working for a company, they're going to have a lot more specifics on what you have to do there, because you have to do all sorts of code tracking, and I mean it's actually very critical. But anyway, let's get back to here. Well, the first thing I want to do here is do some pound defines. And the first thing I'm going to do, and it doesn't matter what order we do these in, but I'm like, all those registers, all those stuff where the data is stored, I'm going to put data registers here. So these are all the registers where data is stored. And so I'm going to do some pound defines here. And I'm going to first do, and just kind of go back to the data sheet and say, oh look, they have a pressure, and I'm just actually going to copy and paste it here, so PADC. But what I'm going to do here is put an MPL115A2. You might say, is that really necessary to put that? Well, technically it's not necessary, but it's good coding practice, because we could have another sensor that we're using that also has a pressure ADC analog to digital conversion with a most significant byte and a least significant byte. So we want to make sure that we can avoid variable collisions or pound defined collisions, because these aren't really variables, these are macros. But we want to make sure that we avoid any kind of macro or variable collision, and the best way to do that is to make sure that you come up with unique names. And so we can do some copying and pasting here though, because least significant byte, not that would be 0, 1. And then actually what I'm going to do here is copy these, and temperature, most significant byte, least significant byte. And then if I go back here, the next one is A0, then B1, B2, C12. Now I need to change these numbers as well. So A0, A0, 4, 5, and then I'm going to just copy these two things again. B1, B1, this would be 6, 7, copy those lines, and this would be B2, and then this would be 7. Sorry, this would be 8, 9, there we go. And then this would be C12, C12, A, and B. And then this is why, again, having a double monitor, I could set the screen up for, showing two things. It's actually a super wide screen, but I'm just leaving it tabbing back and forth. But that's why it would be nice having a double monitor here, because then you could throw it up on one side. But I couldn't also record it that way, so that's why I'm not doing that as well. Or if you don't have a double monitor, I keep calling it a dual monitor, print it out. I think it's easier to print it out because then we can do it. Now you might see these reserved, and then you might say convert. Well, that's not, remember though, that's not a data, that's actually a command. So those are my data registers, and then I'm going to just put in here commands, because I have essentially one command, pound define MPL115A2 convert, and that is 12 hexadecimal, of course. Okay, so we still have one more here that we should put in here, and that's the device address. So pound define MPL115A2 address 0x60. Alright, so we've got most of the macros. We might need a couple extras, but I can't think of any right now off the top of my head referring to the data sheet. So the next thing we need to do, of course, is I mean, as I said, you can do these in an order, but then the thing I like to do here first is do function prototypes. So these are the functions we're going to get. Now, because of the way we use PSOC, and I like to model the things after PSOC. PSOC, I think the way they do their APIs for the components is actually very a good process or a good method to do it. So one of the things we're going to do as far as a function prototype is we're going to have an MPL 115A2. We'll have a start command. Now remember, we have to actually give it a function prototype. So the start command should be a void function as far as it doesn't return anything, and then we're not going to need anything to input it. Now there's actually not a startup process that we need for this, because remember, as soon as you put on and I forgot you need a semicolon here. As soon as you power up the device, it's ready to start doing measurements. So you might say, well, what's the start command? But remember, we had to read the coefficients in once. So reading the coefficients in would be a good thing to do in the start command, because you're going to do it once. And then, of course, some other ones here is, well, I need to have a function to get my pressure and temperature. So I might say MPL115A2 underscore read press, And that's going to be a void function too. I'm not going to give it anything. And then you might say, okay, well, read temp. And now there's another one that I'm going to add here, which technically isn't necessary, but we're going to use this one here. MPL115A2 underscore read. I'm going to just call it both. Actually, that's not good. Read press temp. That's what I'll call it. I don't know what I called it in class, but that's what I'm going to call it. But now it's a reason it's a void function. You can only return one number. Now we could maybe say it shouldn't be a void function, that we should have some error code, and maybe we should. But for now we're going to just leave it as a void function. But the way we're going to get the two variables is we're going to use pointers, and so we're going to have I should tell it needs to be a float, and it's going to be pressure, and then float temp for temperature. Now that's all we're going to do with this one. I'm going to put in a comment here because this might be something you should do. You would need another pin. You need an output pin, like just a digital I/O pin on the PSOC device. So you'd actually have 5 wires then going to a power and ground, the serial, and then a data wire, just like just a normal output pin, one of the GPIOs. But we could have MPL115A2 shutdown void MPL115A2 wake up void. And we could use those commands because, again, remember, the reason you might want to put it in shutdown mode is because in shutdown mode it consumes very little current, so there's going to be very little power, so we're going to have battery and energy savings. Okay, there's one other thing though that I know we're going to have to do here, because if I'm reading these coefficients in, I know I'm going to need them in my computations for pressure. So I know I need to have some variables here. Some global variables is what I'll call them. And I'm going to set them up as externs. Float. And then when I do global variables, this is not like a, oh, you must do this kind of thing, but I like to do them all in lowercase and put an underscore in front of them. And so I'm going to need, I'm going to need one for each of the coefficients. So I'm going to need a B1, B2, and then a C12. All right, but that's my header file, at least for now. I mean, if we think, oh, wait, we might need some additional things in my header file, we can always go back and add them in. Okay, so that's going to mark the end of this video.